BSD security fundamentals. This is just going to, like, hopefully at the end of this talk you guys will have a little bit better understanding of some of the security mechanisms that are actually built right into BSD, and a lot of people just don't make use of them, and they're actually pretty nifty. So yeah, I'm just going to get started. It's 3 o'clock. I'm going to throw this presentation up. You'll have to excuse my PowerPoint format. It's not very polished. I just throw as much stuff in there, so I remember so I don't leave anything out when I'm giving the talk. So this will be up on the. This is a little bit different than the one in your CD. It's a couple more revisions to it. So go ahead and the website is going to be subtrain.net/presentations, and you can get some of the other talks that the rest of the guys that I work with have done. So subtrain.net/presentations. Okay, so for this whole talk, I'm pretty much going to be focusing on FreeBSD. That's like the main operating system that my friends and I work with, and it's really the most mainstream. And I mean, I'll like deviate a little bit and talk about some cool stuff with OpenBSD, but it's mainly going to be FreeBSD. It's going to be a refresher. I mean, some of you guys may already know a lot of this stuff, but I mean, I'm sure everybody will pick up a couple things that they didn't know or they think's pretty cool. And it's going to emphasize on host-based security, and I'm just going to basically show you, using a defense in-depth strategy, you're able to secure a BSD server, all the way up to the wire pretty much, and it's like the models of the security onion. You know what I mean? You peel it away. A lot of people, I mean, it's ridiculous with like the recent Apache chunked encoding stuff. I mean, I'm sure some of you guys came across this, but a lot of people actually went out of their way to start up Apache running as root because they didn't understand how file permissions work and symlinks work, and they just wanted Apache to have access to their entire directory structure. So once they got hit by the exploit, they were toast. So okay, so BSD is actually in use in quite a few different products in today's like computer enterprise world, and it's kind of behind the scenes a lot of times. A lot of companies are kind of turning to open source right now with like the current state of the economy because they don't want to pay the high support costs for licensing Microsoft software or some other commercial variant, and a lot of times the quality of the software is, as you guys know, usually better. Nokia firewalls they run Checkpoint. They use what's called the IPSO operating system, which is like a hardened version of FreeBSD 3.2, and they've just went ahead and done some extra like file locking and stuff, and they've got some proprietary stuff that they've added. It's pretty cool. And then all the Juniper, all the backbone routers and stuff, they all run FreeBSD. I think it's called Olive is the name of the product, but it's more or less a BSD machine. You can do package add on it and all kinds of stuff. They're pretty cool. And of course, everybody knows Yahoo uses FreeBSD clustered machines to power all their web stuff and their mail stuff. So all right, so let's get started with the basics. I mean, everybody should know this, but I thought I'd just go over it anyways. If you're messing with a system that's in a production environment, make backups. Don't make any changes you're not comfortable with if you don't know what it's going to do. Go through your inid conf file and rcconf file and just turn off what you're not using. I mean, FreeBSD especially has gotten really good lately in the last couple of releases, and I think all the way back to like 4.3, they've just turned almost everything off by default in inid, which is like, I mean, they're really like setting the pace for other vendors, because I mean, up till just like maybe a year ago, the standard was just vendors were more concerned about making stuff work out of the box rather than emphasizing security. So I mean, they would just turn everything on by default to make it easier for the customer, which didn't turn out to be a very good security strategy. If you're running a machine and all you need to do is send mail locally, you can actually disable send mail, disable the daemon mode of send mail in the rcconf file with some flags. And you can also turn off the submission port. Send mail comes default with FreeBSD, in case some of you guys didn't know that. And the submission port is just another. I think it's new to like send mail, like late versions 8.11 and 8.12, and most mail servers don't make use of it, so you can firewall it off or disable it in the rcconf. I'll get into how to do that specifically in a little bit. And obviously, I mean, you're going to want to track the most stable version of the operating system. If you're working in a production environment, I would say probably rebuild the system and rebuild the kernel like every 2 months or maybe every month and a half. Obviously make exceptions. I know just recently we've had some problems with OpenSSH, and the FreeBSD team got the 3.4 stuff with the privilege separation put into the stable tree pretty quickly after that, even though stable wasn't actually affected by the recent off by one and some of the other remote OpenSSH stuff that's been floating around. If you're a hobbyist, I'd say go for it as much as possible. I think I could probably count on one hand in the past 3 or 4 years the times that I've seen the stable tree really broken to the point where you couldn't, kind of figure out what was wrong, or if maybe somebody just made a fat-fingered something when they did their commit, and it got taken care of, within 30 minutes or an hour or so. I think that, I'm not sure about this. I'm not sure if they've gotten rid of this, but there's another branch called the security branch, and basically that's like an option for you if you're running a production system and you don't want to. You don't think stable is really stable, basically, but you want all the security fixes, and all they do is commit anything like the recent like IO smash stuff. They just commit patches to that, and then that's all you get. And a lot of people prefer that if they're looking to run a really stable environment. And there's the recent OpenSSL stuff that I was checking out before I headed out to Black Hat this week, but it looks like there have been 5 or 6 new vulnerabilities found in OpenSSL, so rebuild your systems when you get home. Okay, encrypted communications. I mean, especially at DEF CON, I was really amazed the amount of people that were still like popping their mail and everything at like DEF CON 10. It's kind of ridiculous, but more or less, I don't think there's an excuse to not encrypt stuff that you're doing. Between SSH tunnels or using S-tunnel to wrap stuff with SSL, what's your excuse for not doing that? And OpenSSH has been included in the FreeBSD base since I think FreeBSD 4.0. A lot of people have chosen to track the port though and use port upgrade to just keep it current. And you can actually, there's an RCComp variable, I think it's SSHD_daemon, and you can just specify the path to your SSH daemon, so you can put it wherever you want. Personally, I just stick with what's in stable. I never had a problem with it. Even if with some of the recent OpenSSH disclosures, people were kind of muddy as to what was affected, where, and under what circumstances. So I just recommend going through and upgrading all your systems to 3.4 and disabling SSH version 1 where you can on some older systems, especially some legacy stuff. Like I know, like Pix firewalls and stuff, they only listen on to SSH version 1 for the protocol. So that might be a problem, but on your BSD systems, you really have no excuse not to. And you can turn on privilege separation. It's not enabled by default with 3.4. You have to go in there and turn it on. It's an option in the SSHD config file, and it's just like, I think it's enable or use privilege separation. And basically that'll just fork off a process when somebody authenticates to your machine successfully, and it'll drop some privileges. I'll get into that a little bit later as to how some of that stuff works. SFTP, this is kind of recent. I think it's like OpenSSH 2.9 brought it in to the tree like as a standard thing, but it's just basically a way to connect to your system to transfer files over SSH. And obviously, the problems with FTP, everybody knows. Some of you guys may have caught Jay Beal's talk yesterday about hardening FTP. The FTP is 20 years old and passes stuff in the clear and uses an unauthenticated channel for data and everything. It's just this way it's encrypted. This has full public key support. So it's basically just like you're making a administrative connection into the machine. And there's some neat clients for Windows, like SecureFX, and I'm not sure if PuTTY has a file transfer client or not, but it's a lot more secure than using regular FTP. Okay, public key authentication. Just talking about this a little bit. Really, what's going to get you I mean, most people are pretty good, like, keeping their systems patched that are in the security industry, and, you know, or they're a security engineer at their company or what have you. I mean, they understand the importance of rolling patches out in a timely manner, but what's going to get you are your users, usually with weak passwords. And so I'm going to talk quite a bit about how to secure your user accounts. And what it comes down to is, you know, users don't really give a crap about security, and that's just the way it is. I don't know if that'll ever change, because I mean, people want convenience and they want to be able to use their system, and security and convenience are just kind of like opposites. So I'm going to talk about public key authentication, and I'm going to heavily recommend switching all users to public key authentication if your users are savvy enough to handle it. You know, you may have to have them help them set up the public-private key pair and everything, but once you do it, you can actually star out their password fields in the password database, and you know, they won't be able to log in with a Unix password scheme anymore. If you can't do that, I've got some alternatives later in the talk that I'll get into. Okay, so I'm just going to get started, like, as you're installing, like, you know, you're setting up a new machine or whatever. It's always good to consider security right as you're building the system, and how your partition scheme looks is really important to that. As much as you can, break it up into different partitions. So at the minimum here, I've got like a root partition, user var temp as a minimum. /home should definitely be considered as a separate partition, just because I mean, depending on the level of security you're looking for on your BSD machine, with some of the mount options and some of the other stuff you can do, you can really restrict what users can and can't do on the file system. So like anything except user or / because of SBIN, you can mount those with a no suid argument, and basically that's just gonna, if there's a file with a suid bit set on it, it won't execute with that flag passed through mount. And I would also recommend setting that on your home partition too, just because, you know, users, if they're messing around with something and it's suid, especially if it's suid root, you know, you don't really know what they're doing. Go through your file system and remove suid bits. I was looking through the FreeBSD handbook just to see what the project's stance was on this, and they say, you know, anything that's set suid in the default installation is probably pretty safe. But if you're not using stuff, for example, if any of the UUCP stuff, I mean, you can actually strip that right out in your make.conf file. You can just say don't build UUCP, because, you know, who uses that anymore? But just go through your file system and look for suid and SGID files, and just get rid of those. Anything you don't use, either just remove the bit or just set the file 000, so if nobody's using it. The CH flag stuff, I'm going to get into that right now and in the next couple slides. Like extended, most people actually don't really know about this. It was kind of interesting to me that most people didn't find out about this, but this is like other variables you can set on a file that when you're using kernel secure levels, you can like restrict access to the file. A couple of the ones I've got here are like the sappend, like a log file. That'd be like a log file or a text file type of a thing, where you've got data incrementing to the file, but you don't want anything else. You know, anything else, you don't want someone going in there and erasing their tracks or something. So all they can do is append data. All the file system will let them do is append data. You can't do anything else. And the SCHG bit you can set on binaries, system binaries, and that'll just prevent modification, overwriting, deleting, and as long as you're running in a secure level of 1 or higher, not even root can modify that. So it kind of makes it a pain if you're rebuilding your system, because you have to reboot into a non-secure mode and then clear all those or, you know, rebuild your system or whatever, overwrite the binaries, and then reset all the flags to whatever you had before. So I mean, it depends on the amount of time that you want to spend configuring this stuff. If you get really granular, the interesting thing I ran into was people were complaining that, if you set your whole like sbin and bin directories with the SCHG flag, you couldn't tell if somebody had broken into your system because they weren't able to modify data. People were getting pissed off because they weren't getting any tripwire reports because nobody could modify the files.
Yo, shut that shit down.
Nice. Okay, so kernel secure levels, basically you can change these. These are variables you can change on the fly. You can't lower them though once the system is in multi-user mode. The only real fault with kernel secure levels is that it doesn't, the secure level doesn't get set until very late in the boot process. So if you're kind of paranoid about that and you think maybe one of your startup scripts has been modified and somebody's doing something nasty before your secure level gets raised, it's always best to set that SCHG bit on your RC files or some of your other startup files to prevent modification of those. So the levels go from -1 to 3. -1 and 0 are kind of the same thing. They're just in secure mode. And secure level 1 is, you can set the append and the SCHG flags, and you can't disable them once they're set, and you can't load any LKMs, load kernel modules. You can't load or unload those in secure level 1. Secure level 2 is the same thing, but you can't write to disks in a raw fashion except for mount, and also time changes. Any changes to the system clock are clamped to plus or minus 1 second change. So if you're running a PC or something doesn't keep time very well, when you reboot your system to drop it into secure level 0 to rebuild your system, you're going to want to go ahead and set your clock then, because if you don't, you'll just get errors in your log files about the time changes clamped to 1 second. Okay, so yeah, we talked about that, setting the SCHG flag on some of the your system binary directories. Okay, this is a lot of data, I know, and if you can't read it, that's cool. Just grab this is all on the CD, and this is going to be up on the website too. Basically, there's sysctl variables. That's also the secure level configurations for FreeBSD is a sysctl variable, and it's just a numerical value, -1 to 3. But these are some other settings that a lot of people don't really know about, that can actually kind of help you strengthen your network stack a little bit, and kind of keep people guessing as to what you're running, and it kind of pisses people off that are trying to port scan you. The TCP black hole variable is the first one I'll talk about, and you can set that to 0, 1, or 2. Basically, I'm just going to recommend 2 in almost any case, which is a totally silent mode where it's just not going to generate reset packets back to the source on any connection attempts to a port that has no socket open, nothing listening. So if somebody throws a port scan at you that opens up ports 0 through 10,000, you've got 3 things running on those 10,000 ports. You're just going to sit there and they're in timeout. They're just going to be waiting for a reset packet back to see if your port is closed or not. And there's the same setting for UDP, and basically that's the same procedure, same idea, except that it won't generate an ICMP port unreachable message on a port with no socket listening. So same thing. That will break traceroute to your system. So if you care about people being able to traceroute to you, you may want to drop that to 0 or disable it. But so here's some other RC conf settings that you can do. This is how you turn on secure levels in the main RC conf file. You have to enable it, specify enable it, and then set the number that you want. Secure level 3 is the same thing as secure level 2, except you can't modify IPFW rules, which can kind of be a pain if you're initially building your system or something, or you're adding services, because you're going to have to bounce the machine if you want to make any changes to your firewall rule base. So that's just maybe something you want to keep in mind as you're setting that up. ICMP drop redirect. This is going to drop any redirect packets from, supposedly they're supposed to come from a router, but it's just going to drop them from anywhere, and it's just going to prevent people from modifying the path that your traffic is taking. And then there's the TCP drop SYNFIN, and that's just going to drop any packets with the SYN and the FIN bit sets. And it does break an RFC technically, It's not RFC compliant, but you know, there's no legitimate use for traffic with both of those bits set at the same time. So, you know, I would recommend enabling it anyways. Clear temp enable is kind of cool. It'll just go through and wipe stuff in your temp directory on reboot. And one other one, I don't know if I put it in here later or not, is FSCK_Y_enable equals yes. It's a really handy setting if your machine is co-located or something and you don't have physical access to it. If your machine gets bounced or if it crashes or something and it comes back up and starts up FSCK to check out your file systems, this will just automatically, you know, accept any changes that FSCK is going to make, so you won't have to call somebody up and go, hey, go over to the console and press Y a few times. Go ahead. Yeah, it's FSCK_Y_enable equals yes. Go ahead. You can't. I've heard of people compiling like the Riser FS stuff under BSD, but that's all like, I've got a friend of mine in the UK that works on the current stuff a lot, and he's really into like the cutting edge stuff. I've heard that they're thinking of integrating journaling stuff into UFS for 5.0, but I haven't confirmed that yet. So
BSD has no real journal.
not by default, I don't think. Go ahead.
Soft updates, which is read the paper and in some ways better.
Well, yeah, it's kind of it's a philosophical. This guy pointed out soft updates is an option that you can set on your file systems. Soft updates is kind of interesting in the way that it writes to the disk. Sometimes it won't actually write changes to the disk for up to a minute, and so it's kind of a trade-off if you want to enable that or not. If you're doing a lot like heavy disk-intensive stuff, FreeBSD recommends you turn on soft updates, and I think it actually turns it on by default when you set up a partition. Where does it store what?
Those updates that are made yet.
Those he says where the updates stored, they're in memory, and they're just waiting to be written to the disk.
So if the machine crashes.
Right. If your machine crashes, your SOL for whatever data was written up to a minute or prior to a minute. Okay. The two kind of like parts of this talk are encrypting your traffic and starting services in a jail environment. I mean, so many services that you're going to see run nowadays have either native support for a jail like Bind or Apache, or you can use, there's a jail functionality built into FreeBSD. You can build a separate jail for any service that you're running pretty much. And I mean, you can lock that down to a specific part of the file system and restrict people. And I mean, by default, and SSH is kind of the newest one to do this with the privilege separation and and fork off a separate process for each user. But by default, I think that probably services like Bind, and Apache's already done this, where when you do a FreeBSD install, you're going to get the www user, and I think the Apache ports tree is updated now where the default username and group name that Apache runs under is www. So, I mean, people have been using Nobody for a while, but people didn't really understand that if you use Nobody and you run 4 or 5 different services as Nobody, it's not an unprivileged user anymore. So, I mean, you definitely need to break it out into separate users. And with SSH, they've added an SSH user, and the jail for that is /var/empty. Okay, for log in vain, this is kind of like, this will pop up in your D message, and you can configure this to drop into your messages file through syslog. This is just going to show any connections to your machine on ports that aren't listening. So obviously this is going to sort of conflict with some of the black hole stuff that I was talking about a few slides back. But if you set this, you're quickly going to tell if somebody's port scanning you or something. You're going to see a bunch of connections on ports that you aren't even listening on. So this is, and it's definitely, a lot of people kind of mistake this rcconf variable for like some kind of packet filtering stuff. It's not that. All it does is report people connecting on ports that you're not using. So, use it in conjunction with a nice IPF or IPFW rule set. Okay, so the next thing is using IPF on almost any system, and a lot of people take the mindset that, you know, they're behind their corporate firewall, you know, they're inside their office network, you know, nobody really malicious is doing anything. But even if it's just, you know, your laptop or something, I mean, it can't hurt to throw a nice IPFW rule set on your laptop and keep people out. I'm sure a lot of people had that pay off at DEF CON this year, you know. I mean, and it's really easy. If you go to if you look at in the etc directory, there's an RC firewall file, and I think I'll get into that later on, but I kind of want to get ahead of it. Oh, go ahead.
What is the performance impact of using packet filtering with a couple dozen tools on a busy system?
He says, what's the performance impact on a couple dozen rule set IPFW setup on a busy system? It depends what you define as a busy system, and it depends how fast your link speed is, and it depends on the specs of the machine. Personally, I've seen a machine take like 80 or 90 megabits of traffic that it was filtering, and it was like a 1 gigahertz Pentium 3 or something, and you could tell that the load was noticeable. I don't really have any measurable data to give you, but I would say probably like a 20 or 30% impact. But that's with the full out 80 megabit right across a fast Ethernet link. It was dropping every single packet. So. Okay, a lot of people have kind of, they say, you know, I'd like SFTP and everything, but I'm running an anonymous file archive, or I've got users who need FTP. They don't want to learn a new client, even though it's kind of transparent as to the differences. You know, they have some old scripts or something that are using FTP that they can't convert, whatever reason. I would not recommend using FTP really anymore unless you're running an anonymous archive, and I'll kind of show you how to lock it down. But you know, if you've got any users logging in individually, put their username in the etc ftp chroot file, and that's just going to basically restrict them to their home directory. By default, they're not going to be restricted. They're going to just be able to move all around the file system. And so if you've been kind of lax with your file permissions somewhere else, you know, they may have access to something that you don't want them to have access to. If you start FTP from inetd, you can go in and stick some of these flags right at the end. -L twice will enable extended logging, and then you actually have to turn on logging for the FTP facility in syslog. That's going to give you each connection, each user's connecting, you know, time and date, and also any files that they're uploading or downloading. And so the files can get kind of verbose. It's kind of similar to the xforlog functionality in Linux. And so if you're running an anonymous archive, use like "A" and "R", and capital A is only going to allow anonymous connections, nothing else, which is handy because nobody's going to figure out that they can FTP into your machine when you really don't want them to, even though they're a legitimate user. And "R" is read-only mode, where the daemon will actually restrict itself from making any write calls to the system at all. So in the event that somebody figures out how to overflow your because FTPD runs as root, so you know, if somebody figures out how to overflow that, it's not going to be able to write anything to the machine. Okay, logging is obviously very important. Keeping track of your system, and before I get into any of this, obviously logging, you have to spend the time looking at your logs on your system so you know what's routine and you know what's not routine. Because if you see something out of the ordinary that kind of looks out of the ordinary just because you say that's not really right, if you don't have like data to back that up, you know, say I haven't seen something like that in a month or something, or I've never seen that before, that's going to be a lot, more of a clue into you that, hey, something funny is going on. If you're running like a regular workstation, I would recommend this. Start syslog with the -SS flags, and that's just going to prevent the daemon from opening the UDP port 514. By default, FreeBSD won't let any users connect to your syslog daemon to log, and a lot of operating systems didn't used to do that, and so people could fill up your logs, or at the very worst fill up your whole file system if you didn't have permissions set up right. Someone would just allow unauthenticated connections from anywhere. this is gonna keep anybody from being able to connect to your syslog-d at all. I would recommend setting up a centralized syslog file, especially if you're running an enterprise and you've got 10 or 20 different servers maybe. It's much easier to send all the data to a central place, and then maybe even pull the data into some kind of an Excel spreadsheet or something for quick sorting or a database. This is the syntax to do it. This is the wildcard right here is just saying log anything on any facility to remotehost.org, and you can obviously fill that in with a local IP address or something. You will not be able to use this -ss thing up here though. With the machine that you're sending the logs to, obviously it needs to have that port open to be able to accept the logs. In your syslog conf file, add this varlog ftpd or whatever you want to call it if you're running an FTP server, so that you can you get more information about what's going on with FTP. I think by default it doesn't log anything that's going on with FTP at all, or maybe it drops it into messages, which is kind of kludgy because there's so much other stuff going on in that file. It's kind of hard to keep track. The security file, IPFW uses the security facility, and so do a few other applications, but at the end of your IPFW rule base, drop like because it'll just do it just goes down the rule base, and if a packet doesn't match, it'll drop to the next rule. At the end, put a log any rule, and anything that didn't match any of your other packets is going to go ahead and get dropped into that file. I'm sure most of you guys have heard of this. There's a dshield.org project, and they have a client framework for IPFW logs, and it's just a Perl script that goes through and parses it out and changes the data into the dshield compatible data, and then you could set up a cron script or something to email that data every night or something. People connecting to your machine. And then you can go and log in through the web and take a look at it, and you can coordinate it with other people. Other people submit their logs all around the world. It's pretty cool. Yeah.
Some versions of FTP use a file called FTP users.
Right.
And this is people who don't want to be able to use FTP.
Yeah, and what he said, the FTP users file, you can drop users in there that you don't want to be able to use FTP at all, and so obviously you're going to want to drop root and obviously any privileged user, you don't want them passing their password in clear text, and that's a good add-on to the rest of the FTP stuff, the FTP chroot and everything else. Some of this stuff is kind of interesting. This isn't default with BSD. But I ran across a couple of these projects just doing a little bit of research. Trojanproof.org, they actually have a really cool white paper on their webpage about how they developed this tool. But I think they started with OpenBSD and they moved to FreeBSD for development. And it's kind of it's almost like Tripwire, but in the kernel, and it can tell you if there are any MD5 variations, if something's changed with files that are executing on your system. So as they're executing, it goes ahead and does the hash on the file to see if it's changed. And they have some performance specs, because a lot of people were concerned about performance on an enterprise machine, obviously, and I think to benchmark it, they built the kernel with this enabled in the kernel and then this without, and I think there's a 12-second difference or a 2-second difference. I can't remember which, but it really wasn't that bad. And so that kind of works well with another file integrity tool like Tripwire, and that's just gonna give you the kernel level MD5 checking, and go ahead and check out the website. They can explain it much better than I can as far as if you're interested in the specifics of how it works. The next one is server.sf.net. This does system call interception and logging of any what you might deem potentially dangerous system calls. So I've got a few listed here: execve, ptrace, setuid. You can configure every single one of these through sysctl commands. So you can say, I think that setuid call is really dangerous, alert and block it. Or you can say, I think ptrace, I just want to log any of that. Or I don't want to do anything with execve, for example. So you can configure it to whatever settings you want, and The author actually has some recommended settings if you're not really sure what's what. You really kind of have to tweak it for your environment to see what your system is using. And there's a tool called systrace that was actually written for OpenBSD, and a guy at Black Hat this week showed that he ported it to FreeBSD. And what systrace does is it'll basically log system calls that are being used by a particular process, and then block ones that are not in what's called like a rules file for it. So you initially set it up and you run it with like a wrapper, like a TCP wrapper. So you execute systrace, and then I think it's like -a, and then the daemon, and it'll start up and it'll log the syscalls that it uses. So you can go ahead and put it through its paces. We'll say for SSH, you log in, do an SCP, copy a file over or whatever, and then it'll drop all that stuff into a text file. It's like a rules file, and then you can say, okay, that's everything that it can do. Don't let it do anything else. And so, if you attempt like an off-by-one exploit or something on your SSH daemon, if it uses a system call that isn't used by SSH legitimately, it's just gonna drop it. So that's kind of nifty. BPF in your kernel is enabled by default. I think you're only allowed 2 concurrent BPF filters in the generic kernel, but if you're running a production machine, you have no need for promiscuous mode or any kind of real raw packet sniffing type stuff on your system. You should probably turn this off. If you do this in conjunction with setting secure levels on your machine, so an intruder couldn't load a kernel module or something to make a change, that's just going to prevent people from sniffing on your wire. And another thing that you may want to do is write a script to check your dmessage output to see if anyone's put your interface into promiscuous mode and you don't know about it. So you could use like Swatch or something to monitor the logs and send you an email. But I mean, BPF is used by other things. Any kind of like some like real raw IP stuff may use it, so you probably want to test it out on a non-production system before you do that on anything that's production. Okay, this part's called keeping people out, and it's some of it's pretty basic, but a lot of people don't really use TCP wrappers and they should for non-public services, for like SSH authentication, stuff that people aren't connecting to anonymously. For example, like people sending you email connecting to your SMTP server, or browsing your website or whatever. I mean, you can't use TCP wrappers with that stuff, obviously, because you don't know who's coming. But for SSH and FTP, if you've only got a select group of people using FTP, I mean, the more you lock it down, the better you're off. And so like TCP wrappers combined with a nice IPFW rule set is just going to give you that defense in depth. And you never know when it can pay off. So the next one is allow users and allow groups arguments in the SSHD config file. You can specify certain users or certain groups respectively that are allowed to connect to SSH using SSH. So if you've got a user who's an FTP user and you need to give them a shell for some reason, but you don't want them to come in through SSH, you'd obviously use this to not allow them. I think it's disallow users to not allow. You probably want to double check that. So go ahead. This works well with TCP wrapper usage and privilege separation in OpenSSH. And this last one is give users, people that are only FTPing to the machine, give them a no login shell. Obviously, people have been doing that for years. That's pretty basic. So these are some tools that you can use to check your system, and if you don't know what mmap is, you're probably in the wrong building. Whisker is pretty cool. There's a new Whisker version 2 that RFP is developing. That's the author, and it's a little more modular. So his website is wiretrip.net. You may want to check that out. But the one in the ports tree is Whisker 1.4, which is it works okay for auditing real basic stuff. If you've got an old PHF vulnerability on your network or something. Tripwire. Tripwire is a commercial entity now, but what's called the academic source release of Tripwire is still available for free use. And all you have to do is go in the ports tree and build it, and you actually have to go get the source yourself. It doesn't use the traditional disfiles ports distribution method just because of the way the licensing works. But Tripwire, install it on your system. generate the database, and then keep the database on a floppy disk or something, and go through and just verify that anything that's been changed, you know about, and that can give you real peace of mind as far as what's going on your system. But again, it's only as granular as how you make it and how many files you have it check. And if you have it look at everything, you're going to drive yourself crazy just because the amount of file changes that take place that you don't really realize. And Snort, a lot of people are using Snort on their host machines now because it's a lot easier than kind of doing the combined like log analysis of everything and looking at some of the other your firewall logs and everything else. With Snort, I mean, if something trips a signature, you're kind of interested in what's going on. Go ahead.
I use a lot of Snort and I deal with ACID, but I want something that I guess is more conjunction with it to actually provide you a little defense and anything like that.
Yeah, actually, he asked, can I use Snort for any kind of a defensive mechanism? And there's a tool called Hogwash, and the address for it is hogwash.sourceforge.net, and it's written or co-written by one of the Snort developers. And it's actually being integrated into the Snort CVS tree right now for Snort 1.9. It's going to be called inline Snort. It's just going to be a compile time option. But basically, instead of like an alert, you write a Snort rule, instead of the alert variable to like alert and write to a file or something, you can do drops. And so for a TCP connection, it'll send a reset back as soon as it realizes that the packet matches the payload for, say, like a code red attack or something. And it also has content replacement. So, going back to code red, you could say replace cmd.exe with xyz.com, or replace the first 4 or 5 bytes of a shellcode sled or something with nulls. And those, even if your system isn't patched, you're still going to be protected to an extent, because you're just basically screwing up the exploit, and it kind of confuses the attacker, because if they're sending like a cmd.exe request, they're just going to get back 404 or something, and because their request is being modified halfway through. So it can and that's kind of a mixed blessing, because if they really get clever and they start going, well, hey, what's going on? I know that I was able to get to that 2 days ago or something. They start digging in deeper. They may be able to figure out that you're running something like Hogwash on your network. But a lot of people are actually deploying that outside their firewall to grab stuff before it hits their DMZ, and it's pretty effective. Go ahead.
An alternative to the tripwire for commercial use, AIDE.
Right. Yeah, you just mentioned AIDE is another file integrity tool. Right. I really like Tripwire. I like the signature syntax. It's really flexible, and it's pretty easy to write some pretty custom rules really fast. Okay, just some miscellaneous stuff. You should throw these on all your machines. Like use ntpdate, cron tab it, and have it sync time with an internal time server or something out on the internet, so your logs are always in sync and up to date. I know some of this stuff seems basic, but a lot of people don't do it. In the TTYs file, change the secure flag to insecure on all your local TTYs, and that's just basically going to prevent root from logging in directly. So you're just going to have to force somebody to log in as themselves, and then like su to root or use sudo or something. And also in SSHD config, there's a permit root login, and I think by default it's yes. So obviously change that to no. You don't want people logging into your system as root. I mean, whenever possible, don't use the root password for some kind of authentication. At the very most, use it su to root or something. But if you can, use sudo, because you're just going to be able to restrict who knows the root password on your system, and you can granularly lock down who can do what on your machine, and they don't need the root password. The last one is a kernel configuration that you can do. It's a pseudo device that you can enable called the SNP device, and you can go ahead and use that. I think the tool is called Watch in the user SBIN directory, and you can attach to a TTY on your machine, and it's non-interactive. You can't type back, but you can watch what somebody's doing, and you can monitor them as they're going along. Okay, so here's some related stuff. Here's the link that this presentation is going to be available at with some of the updated info. And freebsd.org/security. I mean, you definitely want to bookmark that and check that out pretty often, because that's where they post all the security advisories, and they also there's like a security how-to that it's kind of outdated. It was written a few years ago, but it's got some good info. And I've got some free stuff for you guys from the FreeBSD Mall guys. I think I've almost got enough for every single person in here. And so, yeah, Murray, the guy who runs FreeBSD Mall, heard I was going to be talking about FreeBSD, and so we were talking. And if you guys want to come up, I've got. Well, actually, hang on. Let me do T-shirts first. Don't move. Everybody likes T-shirts. All right, hang on. I've got to give my plug first. These are made by my friend Tim, and he works for a company called hacksawerwear.com, and nobody else has these T-shirts. These are all like 0 day. So. Hold on.
Sir? Too late, mate. What was your question, sir? What was his comment, ma'am? That's what happens when you resist arrest. Very good, sir. You must be a cop. Next year, folks, spot the Fed. But we're out of shirts, so...